So welcome to using virtual and override, some meaty C++ terms. We're basically going to be focusing on this part of our architecture, the tank player controller talking to the tank, making sure that we've got that reference. And by the end of it, not too much will be happening, but we'll be understanding more about the hierarchy of inheritance, how our player controller inherits from our controller, etc., and then how we extend the functionality of the engine. So I'll see you in there. So in the previous video, we wrote this getControlledTank method. Now, I would be nervous about writing a method not pretty much immediately testing to make sure it works right. We don't really know if getPawn's the right method or is it getControlledPawn. We're not 100% sure this cast is working. We basically want to test it. And to test it, we want to be doing so either in begin play or tick. We want to be able to log out to the console and be able to see that we actually have got a tank and which tank we're possessing. So if we play the game, and then hit F8 to depossess from the tank, we can then get our mouse back and we can go to the content browser and we could have a look, the world outliner, and we could have a look and see that the tank player controller, where is it? Here, yep, this instance of the tank player controller blueprint here is the player controller, and it'll be possessing this tank here, tank BP10. And we can tell that because if we move outside of it and then repossess, we go back to it. And also our control works for this tank. So we are possessing the tank, that's great. So we should be able to get that controlled tank. So let's firstly look at how we would do that in Blueprint. So let's follow the whole story through as to what's going on here. Firstly, let's start in the game mode blueprint. In the game mode blueprint, there's a couple of things we've got set. The default pawn, the thing that we are spawning at the player start that we've put in the world, is the tank blueprint. That's good. And the player controller class is the tank player controller blueprint. Good. You want to make sure yours are set appropriately. So this is what puts the pawn in the world, the tank in the world, and possesses it with the player controller. Now let's take a look at the tank player controller class. The next question here, sorry, not the class, but the blueprint. The next question is here, is this appropriately parented? Well, it isn't actually. I don't know if I didn't do that in the last video or if it lost my changes, but you do need to make sure your tank player controller blueprint under the class settings is parented appropriately to your tank player controller C++ class. That's really important. Okay, so here we are in the tank player controller. Let's just do this test in Blueprint first. If we look for tick, pop ourselves an event tick node. You don't need to do this, by the way, if you don't want. You can just watch this. I'm just doing something diagnostic. And get player pawn. There you go. So get player pawn is a method that will get the player pawn, i.e. the tank that we've put in the scene. If we then take its return value and turn it into a string, and then we do a print, I don't think you've seen this print node before, but this print string node is quite handy. So we change the type that comes out of here into a string, and we print it. Now, where do we want to print it? Well, let's print it both to the screen and the log this time, just for fun. Let's see what this does. Print, play. Okay, I'm just going to depossess to have a look. All over the screen and all over the log is the fact that we are possessing tank BPC_11, which if you look at the world outliner, is this one here. It has an extra C in it, but if you hover over it, you'll see its ID name is matching what's on the screen in the log. So indeed, we are possessing the tank, and the blueprint proves that, and we're using the method getPlayerPawn in here, and that works absolutely fine. So I'm going to delete that diagnostic there. That kind of tests it works from that standpoint, but what we need is a begin play method inside of our C++ class so we can do a similar test in there. It's just that there isn't one. So we need to understand a little bit more about inheritance for this. And overriding. So what is overriding? Well, right up the inheritance tree, let me show you the inheritance tree. If we do player controller Unreal, for example, then if you look at the actual API docs, which is this URL here, you'll see that the player controller inherits from the controller, and the controller inherits from the actor. Okay, and if you were to look in the controller, you would actually find there is no begin play if you did a search for that. It's only actor that has a begin play. So the last time in the hierarchy that begin play was defined would have been in actor, and we know that actors have a begin play. So what happens with this inheritance business? Children inherit their parents' methods. So the controller has inherited begin play from the actor, and then the player controller has inherited from there, and then our tank player controller is inherited in turn. So there's a whole string of inheritance. If we want to use begin play in our method, that is over here in tank player controller, if we want to write simply void begin play, we can. But we want to be sure we're overriding and adding to the functionality that's further up the inheritance tree, because we want to make sure that all that other stuff that Unreal has written is also happening. So the way that you do that is using the keyword override. So we say void begin play, but we type override, and this says, please make sure there is something else up the inheritance tree with exactly this signature, not begin play int when or anything else, but precisely begin play with no parameters. That's what the override does. It checks that it can find this upward in the hierarchy, and it will literally go through all of this until it gets to actor, and at actor it'll define begin play, which is here, and then you can see the signature is virtual void begin play. So that brings us on to what does this virtual word mean? Well, when begin play was first declared up at the actor, they used, tabbing, they will use the keyword virtual, and that says that my children are allowed to override or extend the functionality of this method. That's what the virtual bit does. So if the method was declared virtual in the first place, which this was in the case of begin play, it can be overridden by any ancestor in the future. Furthermore, specifying virtual on an already virtual method has no extra effect. So the general recipe for doing this is you go find the original signature, virtual void begin play, and you use that. So what I'm saying is putting virtual here does nothing. You're kind of saying my children could also override my functionality if we based something else on Tank Player Controller, but actually it doesn't matter whether it's there or not. So here's the general recipe for getting your begin play or your tick back. Let's show you the general recipe, and then I'll try and bring it together for you. It's a bit of a complex topic. How to override a virtual method. Find the signature in the API reference. Okay, well that's what we did. We went to the API reference, we found the signature for begin play eventually, and there it is. Okay, good. So you copy it. And postfix override in the header file. Okay, so these are in your slides, by the way, this recipe for doing this. So you come in here, you do that, you paste the signature, and you postfix with override, which is exactly what we just wrote. And that says, please make sure I'm overriding, check me, keep an eye on me. Define it in the C++ without virtual or override. Okay, so when we define this method, we just want void begin play. So we come up here, we go void, of course we need the class name as always in C++, begin play, matching the signature, and then some curly braces. Oops. Okay, that's cool. So with my insert on, oh my fingers, microphone's right between my face and the keyboard right now. So, all right, what's the next step in the recipe? Here, usually call super in the first line of code. All right, so let's try and bring this together for you. What's happened here is we've said, I want to override and extend the functionality of the begin play method, wherever that is in my parent classes. Here we declare this, define rather the begin play, but we want to start always by going super begin play like that. Now, what that does is it makes sure that the begin play on the super classes is being called. Let's have a look at the tank CPP. You'll see that this isn't that unfamiliar. Look, the boilerplate code already did exactly this, didn't it? If we look at the tank.h, let's start there. It says virtual void begin play override. You see, it's already doing that because somewhere higher than a tank up in the pawn and maybe even higher than that is the begin play definition in the first place. Now, if you look in the tank CPP, we go void begin play, no virtual, no override with the class name, and then we go super, which says call the default behavior before we do anything else. That's why they've laid their boilerplate code out like this, and that's why we are going to do exactly the same thing here. Great. So we have now got to the point where we can log out to say, hey, I'm here, I'm in begin play inside the Tank Player Controller. Let's just do that now before we go any further. Let's just UE log temp, warning, player controller begin play. I'll put a semicolon on because it doesn't make any difference. Of course, all this stuff here needs to be wrapped in text because of the nuances of these macros. And let's just make sure this begin play actually gets called. Compile our code. This stuff on the screen should disappear because we've taken it away in the blueprint now. That was just a test, just to kind of tell the story of what's going on here. If we play, we get player controller begin play called. You see it in the log temp there? Great, so that is working. We have intercepted begin play. The final thing we need to do is just log out whether get controlled tank is actually working or not. So I want you to log out that possessed tank as an exercise just in logging and in protecting pointers. There's a hint for you. But also don't be disappointed if for some reason it does not show you that you're possessing a tank. We'll talk about why briefly in the solution. Just get as far as it logging. Ideally write 2 if statements. Remember your UE log macro, I've just started to use it. Consider an intermediate variable to make things easier to write. Remember you're going to need to use the contents at operator with strings inside a text macro. And the other thing I would say is you probably want to write an if condition so that you check and see if you've actually got a possessed tank. If you haven't, say you haven't to the log, and if you have, say that you have and report what it is. But as I say, if you keep seeing logs to say that you haven't got it, that's fine. We'll talk about why afterwards. There's a subtlety here. Okay, so anyway, just try and get some logging that tells you whether you have or haven't currently got a possessed tank as far as the code is concerned. All right, so writing this sort of logging is really useful for you so that you can tell what's going on. So what we want to do is something like an intermediate variable. Auto possessed tank equals, or better say controlled tank, just to be consistent, equals get controlled tank. All of this is still just so that we can test to see if get controlled tank is working. Right, now we've done that. This thing here is going to be returning a pointer to a tank. You see a star controlled tank. So the first thing you should be doing here is a reflex. If not controlled tank, protect that pointer. You want to be coming in here and doing some sort of logging, saying, if I can copy correctly, here we go, player controller, or controlled player controller, yeah, say where it's coming from, not possessing a tank. Otherwise, you're going to want to log the tank that you are possessing, which is something like this. Player controller possessing %s, something like that. Maybe with a colon so we can see we're expecting something on the end. And then I'm going to use a comma, and I am going to take the control tank, but I'm going to get its name, like so. And then on all of this, we need to put a star to turn this string that would come out of that, or should I say out of all of that lot. This lot here would be a string, so the star turns it back into a tchar star, etc., a quirk of this text macro. And this will tell us whether or not we've got a controlled tank. Let's have a look. It's basically a very similar thing to what we did in Blueprint over here in the C++ now. And we can leave some of that code in, actually. So what's wrong with that? Controlled tank, undeclared identifier. I think I've just misspelt it with a single L. Yep. Simple spelling error. Player controller not possessing a tank. Interesting. Okay, but the log is working. So interesting error, and I suspect it's because my machine crashed just a couple of videos back, just after I had gone to my tank blueprint and reparented it onto, yeah, that's correct, onto the tank C++. So if you're getting a similar error message, it's because you need to make sure that your tank is actually parented onto the tank. And the reason, for those of you who are curious, that was failing is because it wouldn't have been able to cast the pawn that it finds to a tank here if the parenting isn't done properly. So let's try that now. Just recompile that blueprint and play. Great, yep, player controller possessing tank BP_C40. If I just check that in the content browser, the world outliner, that is indeed the tank we're possessing. You can see the yellow outline. All good, fantastic. So let's move on.